All right. Going through the remaining problems. So starting with number 77, it said, guys, try to focus. And again, I'd like to get through all these with you so that you have questions and all answers. On 77, it said find point R on ST so that the ratio to RT is SR to RT is 1 to 2. So on here, this graph splits very nicely. We have a point. We split it right where it's going through these nice whole number of vehicles. This is split into 3 parts. 1, 2, 3. It said it wants SR 1 to 2 with RT. So SR, that's 1 unit. That's 2 units. So that's where our point is. Means that's at the point -3, 6. Let's see. On yes, come on. Yeah. All right, on 78, a sim map is placed on a boarding. The post office is located at the point. We have a point, library, another point, fire station, another point. What is the ratio of the length of PF to the length of ST? So on that one, really we just need to find the length using our distance formula. So we're going to use our distance formula and go P to F. So distance of PF, square root of, I got my point 5 and 35. F was at 9 and 25. So 5 minus 9 is 4. 4 squared is 16. 35 minus 25 is 10. 10 squared is 100. So that is 116. Now, that doesn't really come out to a whole number, so we could simplify it. If we were to simplify this, a whole number, a perfect square that goes into this is 4. So I can split it into 4, and 4 times 29. Square root of 4 is 2, so I got 2 square root of 29. Great. Do the distance formula for the next one. Distance of ST. Plug it in. S. Oh, I forgot. There was a mistake on this problem. There was no ST. That was an issue. Okay, on the answer key, they changed this to LF. So we're going to do this using LF. So we have 15 and 10 as our 2 values for 1. And then F is 9 and 25.
Looks fine to me.
15 minus 9, that's going to be 6. 6 squared is 36.
Our friend.
10 minus 25 is 15. 15 squared is 225. Add those two together. 36 and 225 is 261. Again, we can get a perfect square that goes into this. Would be a 9 this time. So 9
100 grand.
again times 29. So that's 3 radical 29. So look, we got 2 to 3. That's our ratio. 2 to 3. Number 29. Which statement is true about the 2 lines and equations that are given? So they're asking us about are the lines parallel, perpendicular, do they coincide, or they intersect, or are not perpendicular? Well, we need to know the slope for that. This one, you can see the slope. So there's 2. This one, we don't know the slope. We have to change it into a format. Let me know slope. Again, slope intercept form is a good option. So we have to get y by itself. If we get y by itself, then the m value represents slope. So bring x over by subtracting it. So we get negative 5y minus 3x minus 3. Divide by negative 5, and we would get a positive 3/5 x and a positive 3/5. So looking at the slope here compared to that slope, they're not opposite reciprocals. They're not the same, so they're neither parallel nor perpendicular. They are going to intersect, but they're not. perpendicular. On 80, which equation describes the line that passes through that point and is perpendicular to the line described by this one? Again, gotta find the slope. So get it in slope-intercept form. You get negative 2y equals negative 4x plus 6. Again, we subtracted the 4x. You get it over. Divide by 2, negative 2. That's going to be a positive 2x minus 3. Great. We have our slope. We want perpendicular. So our slope is going to be the opposite reciprocal of that. So we need to look at it as a fraction, which is 2 over 1. Flip it and change sign. So it's going to be negative 1/2. This is the slope that we need. So looking at our answer choices, can't be C, can't be E. Now, which one is it going to be? Well, it has to go through this point. So easiest way to check this, instead of plugging it all back in right now and trying to rewrite our equation, just use the two that they gave us and plug in the point and see which one actually has that as a point. So plug in 6. 1/2 of 6 is negative 3. Negative 3 minus 5 is negative 8. That's what we needed. So 8 is our answer. Questions there before I move on? All right, then on 81, move this up. What is the slope-intercept form of the equation line that passes through the point 6, negative 1? That is parallel to y equals 2x minus 3. So, again, two formats that we need to know. Y equals mx plus b. That's slope-intercept. But then you also have to know slope point form. Y minus y1 equals m times x minus x1. That's point slope. So on here, we have this equation. We have a slope. We want it parallel, so it's going to be the same slope. So our slope is going to be 2. And it's passing through that point. So we can use point slope form. Plug it in. Y. This is going to be my x1 and my y1 when I plug in. So oops, I accidentally put equal sign there. Alright, so y minus y1, which is a negative 1, so plus 1, equals slope, so that's 2, times x minus x1, which is 6. Now, they said they want it in slope-intercept form. So I was able to plug into this format, and now I have to change it. Solve for y. The first thing we're going to do is distribute the 2 to both parts. So that's 2x minus 12. And finally, bring the 1 over by subtracting it. We have 2x minus 13. Over here on 82, find the distance from point -37 to the line y equals 1/3 x minus 2. Rounding answer to nearest 10. All right, on this one, we have our coordinate point that they want us to find the distance from. It has to be a perpendicular distance. So this one's kind of a pain, but I would say draw a graph. That's going to be the easiest thing to do. So keep in mind what this is going to look like. This point is in the second quadrant. This line, we have a y-intercept at -2 and then a positive slope, so it's going this way. So try to draw this graph. That's -3. 1. Let's go over here first. -3, 7. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. Over here at -3, 7. Then my line that I have, I'm going to have a point at -2. And then I'm going to have the next point at, I have a slope of 1 over 3. So up 1 over 3. 1, 2, 3. Again, up 1 over 3. 1, 2, 3. So it looks something like that. perpendicular distance. I need a perpendicular line going from here down to that line. So we have a slope of 1/3. The perpendicular slope would be -3. Flip it and change the sign. We're going down 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. So we are intercepting right there. And they want the distance now between those points. So our point here is at 0, -2. This equals square root of -3 -2 squared plus 7 minus -2 squared. 3 squared is going to be 9. This is going to be 9 squared is 81. Add them together. That's 90. So you have square root of 90. It said round. So if we plug that into the calculator and round, it gives us roughly 9.5. Going on to the next one. Questions there? All right. On the next one, it says triangle ABC maps the outline of the park. What is the area of the park? So. All right. Well, we have ourselves a triangle. Now, we can do this a couple different ways. But do the same. That's the right angle. We can use these two as our base and our height. We know it's a right angle because this goes up 2 over 4, and this goes back 2 and up 4. So they are opposite reciprocals, the slopes of those two. Now, we need the length of one of those pieces. They are also the same length. So first, find the length of 2 of those pieces. I'm going to use Pythagorean theorem to find that length. Squared equals the length here, 1, 2, 3, 4. The length here, 2. So 4 squared plus 2 squared. 4 squared is 16. 2 squared is 4. Add them up, that's 20. Take square root.
I should have seen.
Doesn't come out even. So if we simplify it, 4 goes into that. So square root of 4, square root of 5. So that's going to be 2 squared 5. You know what? You want the area though. This length, these lengths are 2 radical 5. For the area, I could have just used this for 20 and been fine. So for area, again, a big triangle, 1/2 base times height. I could just do the square root of 20 here for both of these. If I square root of 20 times square root of 20, it is just going to be 20. That's the same thing as saying 20 squared. And half of 20 is 10. All right, on 84. Yeah, pass it down this. PEFT maps out your dog walking route. If you complete one loop, how far do you walk with your dogs? Round it ants to nearest 10. So notice this length and this length are congruent. This length and this length are congruent. Now this one is 4. It's also 4. These two we don't know, so we have to solve. That's 1 by 1, 2, 3, 4, 5. So we have 2 squared equals 1 squared plus 5 squared. Plug in the Pythagorean theorem again. 1 squared is 1, 5 squared is 25. So c squared equals 26. Take the square root. Now, square root of 26 does not come out to a even value. That would be roughly. About 21. So these are both 5.1. So we're gonna have 4 plus 4 plus 5.1 plus 5.1. That's my third. This gives us 18.2.
Don't throw that hard, so I can really see.
Alright. Questions on that?
Harry, what about
Yes.
He's recording.
Hey, guys.
Sorry.
Hey, guys, I can't hear. Shh, quiet. Simple questions being asked, and I can't hear the question. Stop talking. If you're not asking a question about this, you shouldn't be talking. You have an exam tomorrow. Thank you. Yeah, so I use Pythagorean theorem. I could have done distance formula. Remember, distance formula and Pythagorean theorem are the same thing, really. The only difference is instead of doing the difference in x value, so like x2 minus x1, you're just counting the distance. It's the same thing. It's still finding that difference between your two x's. That's like an a, and then difference between y's. That's my b value. So I use Pythagorean theorem instead of distance, but I use the same thing on both problems. All right, on the next one. Down on 86 now. 86, what is the first step? You would follow to create angle B so that it would be congruent to angle C. So, first step you would follow angle B so it says draw a ray and label it endpoint D. That sounds like a good starting point because that's probably the first thing you have to do, right? You have to have something to start with. You need a ray to copy onto. You can't do anything else until you've done that point. So that's the first one. All right. 86. How could a compass be used to determine if two segments are the same length? So on this one, using a compass, in order to make sure that this is the same length, you just have to open your compass to the length of one and then compare it to the length of the other to see if they're the same. So open the compass to the length of one line segment, then compare the length of the other line segment to the length indicated by the compass. That's it. That's A again. No. Right. No, 7. 87 says you want to construct the perpendicular bisector of a line segment using a compass and a straight edge. Which diagram shows the first steps of the construction? So we have line AB drawn every single time here. And remember, when we did the perpendicular bisector, you had to make a arc, the same arc from each of those points. What had to happen to those arcs? They had to overlap. So on here, are these overlapping? No, they're intersecting at one point. That doesn't work. Here we only have one circle. That doesn't work. On this one, here we have overlapping circles. Here we also have overlapping circles. Which one do you think it is? B or D? B. You know why it's B? So these circles are the same size. Yeah. On here, that means we use the same setting from point B and the same setting from point A, so that both of these points are equal distant from A and B. So both of those have to be on our perpendicular bisector. Since these circles are not the same size, that would not be our perpendicular bisector. So B is the correct answer. She's out right now, but yeah. On 88, you are asked to construct the bisector of angle R. Explain the error in your work. So Looking at this, on here, it looks like we have a point over here, an arc over here, and it looks like these two arcs came from those 2 points. Where are you supposed to draw that first arc from? So the first arc is supposed to start from your vertex, and it should be an arc going this way. Here, they start from over here and did an arc this way. So, you started the construction in the wrong place, you should start at point off. So, C, start the answer. On 89, which type of construction can be accomplished by using the method shown in the diagram? So, this is what we were doing up here. This is our perpendicular bisector.
There you go. You're the best person.
Is B. On 90, what construction is being created by the diagram shown? So, this is what they should have done on that one. We have our arc intersecting both sides, and from both points, we're bringing an arc in the middle, so we're bisecting an angle. That's also option B. Questions on any of those? Alright, 91. Which of the following constructions will create 3 angle bisectors in a triangle? So, in order to create the, so basically they're asking which point of concurrency are we creating? So, angle bisectors make our incenter. The incenter is the center of an inscribed circle. So it's B. I'm making an inscribed circle. Yeah. 92. Which of the following constructions will create a point of concurrency that is equidistant from the vertices of a triangle? So, the point that's equidistant from all the vertices is our circumcenter. So it's the center of our circumscribing circle. So A would be the center, or would be the circle that we would be constructing.
Oh, Jabari, how much Jabari got like that? He said no word.
93. Which statement is the converse of the following? So again, remember, when we're talking about converse and inverse, we have the original statement. Converse is when we switch the order. Inverse is when we negate both parts but leave it in the same order. Our contrapositive is when we switch and negate. So, in this statement, which one is the converse? So, if a polygon has 3 sides, then it's a triangle. So, if it is a triangle, then it has 3 sides. So, that would be D. Just switching, not negating anything. On number 94, if a polygon has 4 right angles, then it is either a square or a rectangle, which is a hypothesis, which is the hypothesis of the conditional, which is the conclusion. Now, again, shouldn't include the if, it's just what follows after the if. So, a polygon has 4 right angles, that's our hypothesis. That's A. Which one's our conclusion? What follows after the then? It is either a square or a rectangle. So, it's either a square or a rectangle. B. 95. Write the conditional statement in the if-then form. You cannot live chat when you log off. So, how can we write that in the if-then form? If you log off, then you cannot live chat. If you log off, then you can chat live. That makes no sense. If you cannot live chat, then you cannot log off. Nope. If you can live chat, then you log off. If you log off, then you cannot live chat. Yeah, that's fake. I don't know why. It's fake. Wrong. Yeah, that's it. All right. 96. Identify the contrapositive of a given statement. Given the given statement, if two angles form a linear pair, then the angles are supplementary. The contrapositive, we have to switch and negate it. So, if the two angles are not supplementary, then they do not form a linear pair. Let's see if we can find that. Are supplementary? Nope. And are not supplementary, then the angles do not form a linear pair. That means we switch and negate it. Good on those? All right, 97. Make it easy. Whoops. Write the first step in a proof by contradiction. Oh, so on that one, if we're doing something by contradiction, we're assuming the opposite. So the opposite on here is this. So if it's saying that it's not equal to 7, then we're assuming that it is equal to 7. So we're doing the opposite. See contradiction, try to prove the opposite. On 28, write the following first step and prove by contradiction of the statement. So they said then B is not a right angle, so we want to prove that it is a right angle. Just C. All right, label that. Almost done. And the last 4. $99. Use the law of syllogism to write a new conditional statement that follows from the pair of two statements. Syllogism is where you connect them and kind of eliminate the middle part. So the then and the if of the first statement and the second statement are the same. We eliminate that part. So then x2, if x is 2, combine the rest. If for x plus 5 is equal to 13, then 5x is equal to 10. So we're just combining those two statements. So it's now these two go together and we have a statement. Use the law of detachment to make a valid conclusion. If an angle is a right angle, then the angle measures 90 degrees. Angle B is a right angle. Therefore, angle B measures 90 degrees. So we're just using the original statement and applying it to the statement that they're giving us. On 101, which is a counterexample for the conditional. If a polygon has 4 right angles, then it is either a square or a rectangle. So we need to find the example that has 4 right angles, but is not a square or a rectangle. C is our counterexample. And then finally, find one counterexample to show that the following conjecture is false. ABC is a right triangle, so A measures 90 degrees. So we need to find one that shows a right triangle. So not this one, not that one. But A cannot be 90 degrees. So here A is 90 degrees. This one, A is not 90. A is at the top. So that's our counterexample. Proving it incorrect. And that is the entire review packet. So if you want to turn it in today, you can. Or if you want to hold on to it, study and turn it in on exam day, that's fine as well.